So we did this, and now we have like 25 minutes to check PureScript concurrency model. First I'll make a comment. So, implement real or implement real world Halogen, or should I say copy? Okay, chat. Let's see. PureScript, concurrency model. Nice. Concurrency support for PureScript, concurrent queues, real PureScript by example. What's this? No, not that. PureScript and avocados. Fibers. First better concurrent. No. PureScript. Async model. Okay, so maybe we can read there. This was a podcast. Working examples. So maybe it's worth to read here. Example of AFs is shown below. Load file. Yeah, this is probably the monad AF context save file. This looks like ordinary synchronous imperative code, but actually operates asynchronously without any callbacks. Error handler is baked in, so you only deal with it when you want to. Okay, that's interesting. So the library contains instances of semigroup, monoid, applicative bind, monad, alt plus. Okay. Monad effect, monad error, and parallel. These instances allow you to compose asynchronous code easily as effect, as well as interact with existing effect code. Escaping callback hell. Hopefully you are using libraries that already use AF, so you don't have to think about callbacks. If you are building your own library, then you can make AF from lower level effect callbacks with make AF. So effect canceller, effect unit, either error. This function expects you to provide a handler which should call the supply callback with the result of the asynchronous computation. You should also return canceller, which is just a cleanup effect. Since AF threads may be killed, threads. Okay, so we are talking about threads. All asynchronous operations should provide a mechanism for unscheduling. I guess it's because they can run in parallel. I mean, although they won't really run in parallel if it's JavaScript, but if this compiles to other language, they could. You should also return canceller, yeah. So pass a function that gets that it's called with a function that takes an either error A. This is the callback after effect unit. Okay, I think I get it now. You should also return cancel. Okay. Effect of compact provides functions for easily binding foreign function interface definitions. Effect fn of response. Okay, accepts a request. And then the callbacks on error on success. Okay, I'm not writing if I yet, so let's just skip that part. But from effect f function, okay. Not good. Our purely synchronous computations can be lifted, yes. Failure. Have a server handling baked in ordinary, you don't have to worry about it. For control flow exceptions, it is avoided. Advised to use except t instead of throwing errors in the app content. Okay. Except t. The support for errors mainly exists to notify you when very bad things happen. However, when you need to deal with AF errors, you have a few options. Alt, monad error, bracketing. Maybe I work on the wrong things, or I don't know, but I don't remember seeing bracketing in JavaScript. I don't know if that's because it's single threaded or what. Working the wrong thing. Because AF has the alt instance, you may also use the operator alternative to provide an alternative computation in the event of failure. Okay, so if this fails, then it requests the other one. That's cool. That's probably I guess it's not too much shorter than the JavaScript version, but has a monad error instance which comes with 3 functions: try, catch error, and throw error. Okay. As I said, I'm a bit tired. Get full. Alright, so it tries this one and try. Okay, let's take a good try. Try. So basically monad error with either. Yes. Pure. Catch throw example. When it's not throw. Now what is the catch? A catch error, pure default response. Okay. What's that catch error do? Catch error X, F calls the error handler F if an error is thrown during the evaluation of X. An implementation is provided for except T and for other monad transformers and library. Okay. I need to do the meme asking. What? No, this is too much. chat. And once again asking you to stay on. Chat, what's up? Okay, so back to this catch, and this catches any error and returns default response, and then it rethrows. Okay. Yeah, this is like try catch code bracketing. After threads can be cancelled, but sometimes we need to guarantee an action gets run even if the presence of exception or cancellation. Using bracket to acquire resources and clean them up. Yeah, that's the use of the bracket. Okay. So forking. Use fork AF. You can fork an asynchronous computation, which means that these activities will not block the current thread of execution. This is the interesting part. Because JavaScript is single-threaded, forking does not actually cause the computation to be run in separate forking. Forking just allows the two transactions to execute without waiting for the forked computation to complete. Yes. That's what I wanted to check. Forking returns a fiber representing the deferred computation. You can kill a fiber with kill fiber, which will, at least it's not like killing children with metaphors with React or something. Which will run any cancellers and clean up, and you can observe fiber's final value with shown fiber. But this will wait for it. If fiber threw an exception, it will return upon joining. Ah, okay. That's cool. So if the fiber throws, you never get it unless you join. Okay, this is interesting. So it will be... Let's call it for 1 second. Let me see what I have there. Okay, I don't have... Actually, I do have something to save. Okay, that's some drawings that I can now clean up. Okay. Hey Danny, how you doing? How is it going? You still in Santa Fe? I didn't ask you last time. What cool troubles have you done with the motorbikes that you have or had? So what I'm doing today, basically I'm checking maybe I can, yeah, this is here. So the app from the other day, I quote unquote finished the login part. So we have the home. Make it clear. Home is just running one component, random component. If we go to the dashboard, it should show us the login. If we copy a valid email from this fake API, and then we put some fake password, it should log in, and then we are in the dashboard. And that's kind of it. Like if I reload in the dashboard, but yeah, we have the session user and localhost, and if I remove this and reload again, we're back. Okay, So the next thing was in the list, check PureScript async async model, and so I'm going through basically the asynchronous effects. Yeah, I'm doing well. Lazy Sunday, basically. So I'm going through the PureScript AF, which is the synchronous effects, and this monad, which is basically the way you handle effects in functional programming. And what we have seen so far is that you can write code that looks synchronous, but it's actually asynchronous. So this is the synchronous thing, and this is another asynchronous thing. You can create them with callbacks, or you can import from FFI callback functions that will produce asynchronous effects. They're called AF, so I'll keep saying AF. And they have alternative instances, so if you use the alternative operation, you can, if it fails, throws, you can provide an alternative. There is one error, so you can try and catch things, bracketing for when it fails, and you still need to like close a file or something. And then forking, this is interesting part. So forking, basically we have the main thread, this is main thread, although it's not a thread. Yeah, basically it's the same thing. I finished this logged in, and now I'm just going through the PureScript way of handling asynchronous thing. I want to understand a bit more. So if it forks, then it runs here, and then it can return. Yes, so let's make this bold, and then let's give names. That was fork F. Both, and then these yes. So I was running initially I was running this build watch and build watch, and this basically just runs the build in watch mode. But then I found out about BSC IDE, and this is also Watcher. Let's take a look at BSC IDE. We're almost done. Almost time to finish. It's like a minimal IDE for shell. So it runs the watcher, and it gives you the errors. Yes, we used to work with something like that. Yeah. But it gives you, I think it gives you like 1 error at a time, if I remember correctly, and it's quite fast. And it, if I'm not mistaken, it runs build also for you. So it's actually, yeah, let's see, build. Let's take a look at PSC IDE help. Lightweight, fast, unintrusive file watcher. Yeah, watches and reveals source files, but it gives you the errors in some nice way. And it's, if I understand correctly, it's based on GHC IDE. Yeah, this is a Halogen project, which is let's see, for example, here we have Halogen from the from here, real world Halogen. I just copied the no, sorry, never mind. It's from the Halogen template, this one, and I just installed PSC IDE separately and I run it here and it works. Sometimes it doesn't build the right thing because I think it builds only like the file you're working with. I'm not sure, so sometimes I had to like terminate it and run the build normally. But if you're working with types, mostly like looking at types and not that code, like they don't want to run code, then you don't have a problem. I think, for example, like now I had the case where I renamed something and I checked the file where I renamed it, but not the places where it was using it. So then I built and I got all the errors for the usages of that change. Yeah, so that, and it comes from GHCID, which is the same thing for Haskell. If I understand, it's based on this name at least. So back to the drawing before I finish. So what I was seeing here, in there is this fork and then there is joint fiber. So that will be oh, I can do that. I can want to do this. That is joint fiber. So this is forked half. In parallel. Oh, it doesn't really run in parallel because this will be the main thread. Yes, doesn't really run in parallel because there is no parallel execution in JavaScript. It's just single threaded. So you can fork, and then when you rejoin here, it will rethrow if the forked thing, and you can kill the fiber. Okay, so maybe this will be like the nice way, and then we can draw one more. Should be let's say that this is an exception. No. except const gets dethroned on joining. What am I doing? Yes. Rethrown. But then you can also fork off. Maybe we can give it another color to this one. Blue. And this one, let's give it red. Actually, this one should do this. And let's say that not what I wanted to do. Main red might kill the fiber. And that will be kill fiber. Okay. And then fiber the forked off is called fiber, which runs in parallel. I like this idea because I guess you could build a real parallelism if you had another backend. So you're compiling to JavaScript, but if you were to compile to Go or some other language, you could build parallelism, or even to machine code. The parallel instance of AF makes writing parallel computations favorite. Okay, so this was saying something here. Because JavaScript single threading forking does not actually cause the computation to be run in separate thread, forking just allows the subsequent actions to execute without waiting. Yes. So this means this and basically means that it's not really parallel because JS, but actually non-blocking. 100. Okay, and I think it's time to finish.